Testing, testing, 1, 2, 3. Always get a few second delay on these sometimes, just something with the screen-o-matic. That's it. I am very excited. Even though this script was mostly put online at the website that I'm finding the Rhino scripts from, what was nice is they had brought in a lot of Rhino script geometry. So they're actually using the more functions and methods and libraries that you get from dealing in Rhino Common, as opposed to in the namespace geometry. So let's look, but I've limited it down to, and of course I haven't put in import math because I'm too excited to do anything. But basically, I opened up two lists and brought in a series of curves, as you can see here, and I output points of their intersection, and then I loft them. Now, everything was done in here in Rhino Common. So if we go into a for loop for curve 1, which is a variable iterating through the amount of curves, which I put in about 6 or 8, and then for 2 curves, it's going to look at those two and say when they're not the same curve, we want to find an intersection x, itxn, which will be, and it's great because they showed me what Rhino Common was for intersect dot intersection dot curve curve, and then we have a curve that's making that with, I guess, a tolerance of 0.0001. So I'm learning that. So I didn't know about that function there, but now I see it, and I'm starting to put that into my vocabulary off of the API on Rhino developers. Then we have another iteration run through here of item in those item lists. So we made those, and we're going to check all the items in there. Please, Max, be quiet. And we're going to see the intersection points and name them intersection point, IP, as item at point A, and we'll append the list with that IP, T. So there we go. That for loop's done. Now we're going to build a geometry at that intersection. So you've got to go in there, find the closest point. And this is good for Rhino syntax and Rhino Common. This is just curve 1. You can grab closest point at IP. So that's good. So you get the T on the parameter. So if you know anything about reparameterized curves from 0 to 1, T is going to be any point between 0 and 1 between there to show you where it is. If success, that's kind of cool. I've never seen that before. I don't even know what to make of that, really, but if success is true, so success is equal to success T is a list. I've never done anything like that before, so that's totally new for me to wrap my head around this section right here. And we're going to have the tangent, and tangent at is another attribute that, or function that can be used at in Rhino script, Rhino Common. It's not specific to that, so you get the tangent vector, and then you're going to multiply that times 2 tan. Whatever that tangent vector is. You're just multiplying it by 2, and then you're going to get a point. So you're going to go back to Rhino geometry, point 3D. So they didn't use Rhino script, 3D point, or whatever it is there, add point. And you can get that at IPT. And then you're going to do the same and iterate that through the tan at point T, and you're going to do the same for 2. So the same thing's happening here as point 2 as for point 1. But what you also need is a point let me see, here's the point at 3D, but you're actually adding 0.3 to a vector to raise it. So I decided to put in a parameter here that I can raise and lower that because Z is actually going to be that. It was hard-coded at 10 in the example. Now here's where the magic was. It had surface is equal to Rhino script syntax. So Rhino script syntax as RS. Add surface point. And I did my work. I saw within here, there's a list of 0.1, 2, and 0.3. 0.3 is that third point, multiplied by that vector to get it up off the curve in the Z, so I can form a triangle of 0.1, 0.2, and 0.3. Now, I wanted to make a surface for that, and I tried everything. I typed in rg.surface, rg. whatever, add rg.object. But I typed in a Google search and just said, hey, how am I supposed to add surface points in Rhino Common? And boom, I never thought to use NURB surfaces. It gets me into a totally different namespace within the Rhino geometry or Rhino.geometry. It gets me into the Rhino Common and create from corners. Makes total sense. Put in your points, 1, 2, 3. You've got it, append it to that surface, and you've got it figured out. So really, this is the type of stuff that when you start figuring this out on your own, you know you could get into Rhino development. So this is what really drags me on and keeps me going. I hope you find it interesting. It's 4 minutes. And yes, it's a simple script that outputs surfaces and points of intersection. It comes off of a script that was 90% there, but I'm really challenging myself to find the alternatives. And in doing so, I'm learning commented out the Rhino script syntax, which is in use next to Rhino geometry, but I'm finding the way that that language translates into here. And I've had it compared to just think of English dialects around the world. Somebody speaks with that accent, somebody has this accent, Scottish, wherever throughout the world in different continents that have been colonized or not. And basically, how do you end up speaking? So hands down, I feel great about that. I'll just keep moving. So I've started a Patreon site. If anybody's interested, you can go in there. I'll deal with you directly. We can talk together a little more in-depthly on what's going on, and I will start sharing in that forum 3DM files and GH files. I'm not going to do that with this series on this Facebook group unless specifically asked, but I really have to kind of prioritize my time because I'm obsessing about going through these scripts. As soon as this Chinese text comes in, I'm going to go back to the basics. I'm going to have all this vocabulary down and the sense of conditionals, and I'm going to be doing great in operators once I get into it. So I hope other people are on this this path with me, this trip with me, and let's see where we end up. Thanks again for watching.